Okay, alright guys, let's start that one. Okay, I need someone to come and close the door and get. Close the door. Thank you very much. Over there. Okay, thank you very much. Alright guys, I need attention. Alright, so let's finish off our chapter 4. Alright? So I want you all to know where are you now. So chapter 4 we are learning something called periodic table. First and foremost, you are being taught group 18. Yeah? Group 18 also known as normal gases. Yeah? After that, we also covered a bit on group 1, sorry. Group 1 is known as alkali metal. After that, we learned something called group 17. Last week, group 17 is called halogens. Understand? We have learned 3 groups so far. So today, we will learn only 2 things to close up this entire chapter. How many things? 2. So the first thing, you don't copy anything first, I just write down here. So today, you will learn 2 things. The first thing you will learn today is called transition element, which I will show you in a short while. It takes about 10 to 15 minutes to finish. The second thing, we will learn something called period number 3. So these are the only 2 things we will learn today. No copy, no need. So as usual guys, when I explain, don't be easy to copy, okay? Listen, try to understand. Any question, just ask me. I'll make sure you've got time to copy later. Yeah? Okay guys, now, today we were learning something called transition element. For me, transition element is the easiest thing in the entire chapter 4. For me, transition element is the simplest thing in this whole chapter. Okay, I'll tell you why in a short while. First and foremost, you must know where is transition element. So where is your transition element? Transition element is always here. This is a periodic table. You can roughly know the shapes, right? The pattern. This is a periodic table. Transition element are all the filler that sandwich or hamburger between twin tower. This is tower number 1. This is tower number 2. Everything in the middle, the hamburger between both, everything here is transition element. Are you clear that? Everything in between twin tower, everything here is transition element. So far so good. Okay, the first thing I want you all to know is this. Okay, the first thing I want you all to know is this. Okay, alright, transition element, where you can find it. Transition elements, it's everything in between group 3 all the way to, group 3 all the way to 12. Everything from 3 to 12 is transition elements. Yeah, this is group 1, this is group 2, 3, 4, 5, 6, 7, blah blah blah. This is 12. Yeah? 13, 14, 15, 16, 17, and 18, for example. Are you hearing that? Okay? Everything between group 3 to 12, they are all transition elements. Okay? Alright. The good thing they can ask you is this. Number 1, I want you all to know all transition element. All the transition elements, they are metals. All transition elements are metals, okay? And it makes perfect sense. Revise. Let's do a quick revision. I taught you this when I first started with this chapter by me saying that if you are from group 1 all the way to 13, you are metals. If let's say you are group 14 all the way to 18, you are non-metals. So everyone take a look on this. So transition element is 3 to 12. 3 to 12 is in between 1 to 13. Understand? That's why transition element, they are metals. Are you hearing that? Alright? Simple as that. Okay, why I say transition element is so easy? Because of this. In SPM, transition elements, okay, can be tested, okay, by, okay, 2 questions only. In your SPM, if they are asking you transition element, there is only 2 questions they can ask. is very predictable. Not the first, then second. As simple as that. Here, the first question they can ask you is this. The first popular question in your paper they ask you is this. What is the physical properties? What is the physical properties of transition elements? What is the physical properties of transition element? Guys, can we do one more round for revision? A quick one here. In this chapter, you have gone through 4 weeks with me, 3 weeks actually, okay? You should realize that they always ask you about physical and chemical properties. Is everyone of you in a classroom able to differentiate what is physical, what is chemical? Physical properties are all the properties which are observable, such as your density, your color, your solid, liquid, gases, okay? Your melting point, your boiling point, all these things called physical properties. Chemical properties are what? Reaction. You can react with what and what you become. Understand? Alright. So what is the physical properties of transition element? I teach you a very, very simple way that you all can use, and you can use this method in your SPM easily. Okay. This is a simple tips. I want you all to know this. Transition elements, they are metals. All transition elements, they are metal. Therefore, transition element, okay, the physical properties. Transition element, the physical properties is exactly same as your metal. You can use all the properties of metals that you learned in PT3 and you can use here. Alright, actually in PT3 you already learned some physical properties of metal, but you might have forgotten. Clear? Alright? So I'll help you to recall back. Guys, come, I want you to participate. Let's try together. Okay guys, any properties regarding metals that you could recall from PT3. What you know about metal? Anyone? Come, just try. Okay, can conduct electricity. I heard the first answer. Okay, the first one. Can conduct electricity. Very good. Okay. Metal is a good conductor. Metal is a good conductor. No matter for heat or even electricity. Metal can conduct heat and electricity very, very well. Very good. Okay, come. One more. Sorry? Shiny surface. Fantastic. Okay, metal is shiny. Very good. Metal is shiny. Okay, and metal is a shiny solid for your information. Most of the metal is solid except one, mercury. But mercury not in your syllabus. Understand? Yeah? Okay, that's why it's okay for you to assume your metal is solid. Understand? Okay, one more. What else do you know about metal? There are plenty of answers. Come on, just one more. Again, what is it? Come, just try. No harm trying, just try. Denser than water. Absolutely. If you throw the metal into water, they sink, right? Yeah, denser than water. You are right, okay? You can say denser than water. Or you can say that the density is higher than water. Very, very good. Okay? Okay guys, I give you a few more. Okay, all the metals has pretty high melting and boiling point. Okay, most of the metal, the melting point is very, very high. Okay, alright, I want to talk about two things very important here. Okay, these two things you will learn in detail. I put star. Okay, and I want to check with you. Listen. Okay, metal has a properties called ductile. Pronunciation, ductile. Another one, metal has another properties called malla. Okay. Malleable. Alright, another property is called malleable. Okay guys, a quick one here. How many of you here do not heard about these two things? Never heard about this. Alright, some of you never heard, very good, okay? Guys, you see, alright, how many of you heard about this before and you understand what is it? So sad, alright? How come no one? Alright, so listen carefully. Shh. Okay. Some of you heard before, some of you doesn't. Even a lot of people heard this in PT3, but they don't understand what is it. Understand? They heard before, but they don't know what is it. Okay, I want you all to understand what is it by today, and you will learn in detail in Form 4, Chapter 9, your last chapter in chemistry. Here, today I give you briefly, listen carefully, I want all of you to know what it means by ductile, what it means by mealable at the end of today's lesson. Okay guys, what it means by ductile. Ductile means can be stretched. Can be stretched. Today, if you have a metal bar, you can stretch the metal, become very long without breaking it. Understand? Metal can be stretched. That is called ductile. Okay, ductile means that can be stretched. The second word called malleable. Malleable means that you can change into different shapes. You can change the shapes easily. Example, today you have a metal, let's say aluminium. The initial shape is actually a cube. You take a hammer, you just knock on it, you will see the whole thing concave. Understand? The shape changed already. You get the idea? Alright? So same thing, today I have a steel bar. Initially the shape is cylinder. If I apply some force, I bend it, the steel bar will become any shape already. Are you hear that? The shape can change easily. That's called malleable. Okay? Malleable means that you can change the shape easily. Okay? So these are some properties for metal you're supposed to know. Are you hear that? Metal is a good conductor. Metal is shiny. Metal, you put in water, they sink. They have a higher density than water. Metal has a high melting point, okay? Metal is ductile. You can stretch the metal, okay? You can pull the metal without breaking it. Metal is malleable. You can change the shape easily by knocking, hammering, whatever thing. Clear? So far so good? Yeah. So what is the moral of story here? What I'm trying to tell you here? You just copy back the properties of metal. Clear? Because transition element, they are metal. They have exactly the same properties as all the metals. Are you hear that? That's how you learn smart. So far so good? Alright. The next one, which is much more important, this is the second and last question they can ask you. Let's do this, then we finish with the transition elements already. The second question, this is very popular. Star, star, star. This is very, very important. Okay, they will ask you, what is the special characteristic of transition elements? What is the special characteristics, of transition elements? Okay, guys, what it means by special characteristic? These are some behavior, these are some properties that they have, other people don't have. Understand? This is what makes them special, okay? So transition element has a few properties that only they have, other people don't have. Here, I will show you, I'll explain to you, I'll prove to you, okay? Okay, how many special characteristics? Got 4. Okay? So you have total 4 special characteristics. You must know, guys. This is a very popular question. You have 4 special characteristics that you need to know. Okay. Number 1, transition element, they have multiple, oxidation number. They have multiple oxidation number. Okay, oxidation number is a word that sounds very weird to you if you are Form 4. Okay, if you are Form 4, you are you find it a bit weird because this is the thing that you should only learn in Form 5, Chapter 3. Okay, Form 5, Chapter 3, you only learn this. So in Form 4, so I cannot wait until Form 5 now. So in Form 4, what you do? In Form 4, when you saw the word oxidation number, you can assume it's a charge. I repeat. Okay, you only learn oxidation number in Form 5, Chapter 3. So in Form 4, if whenever you saw the question say oxidation number in a question, you can assume the oxidation number is referred to the charge. Understand? Transition element has multiple charge. Makes sense. Look at one famous one. The most famous further you must know is iron. Iron can be Fe, 2 plus, what more? Fe 3 plus. Understand? Okay? Transition element have more than one charges. Understand? That's what makes you special. Trust me, other people don't have the privilege. Example, guys, aluminium. Aluminium is not a transition element. What is your charge forever? 3 plus. Understand? Aluminium cannot have other charge already. Okay, let's say magnesium. Magnesium is not a transition element. The charge is forever 2 plus. Understand? See that? If you are not transition element, you only have one charge. Understand? But if you are transition element, you have more than one charges. Clear? That's what makes you special. Clear? Alright? That's what we call this as special characteristics. Understand, everyone? Okay? Good. Okay, next one. Second thing. Transition element, okay? They can form some colored compound. They can form some colored compound, which means that they are very, very colorful. So when you go in the lab, very simple to tell who is transition element. Example, if you go into the lab, you saw there is a bottle, and the bottle inside put a very nice sky blue color. Confirm inside got transition element. If you go in the lab, you see all in sudden there's some powder. The powder is, let's say, brown color. It is transition element. Here, transition element they always show you some colorful thing. What about non-transition element? If you are not transition element, you only have two color. You are white color or you are colorless. Understand? If you are non-transition element, you might be white color or you might be colorless. I feel that. But if you are transition element, you are colorful. Blue, green, and so on. I feel that. Okay, I show you an extra knowledge you don't need to know by now. You see, guys, in your SPM, anything, okay, anything inside that got Cu2 plus, you can assume is blue at the moment. Anything got Fe2 plus is green color. Anything is Fe3 plus, the color will be brown. For now, you don't need to memorize the color yet. You only start to memorize this color in your Form 4, Chapter 8. Understand? Just sooner or later. Okay? For now, no need. For now, you don't need to know the color. Alright? I just want to tell you, for example, today you have a solution. Your solution inside got Cu2 plus. You can expect the solution is blue in color. Today you have a solid, the solid inside got Fe2 plus, you can expect the solid is green. Clear? Transition element, they are very colorful, which is very special. Understand? Yeah? Third one. Transition element can form some complex ion. Okay guys, what is complex ion? Let's break down and use some common sense. Okay? Guys, the word ion means what? Got charge, anyone got charge is called ion. Complex, everyone know complex stands for complicated. So you can form ion, you can form somebody got charge but you are complicated. Let me give you an example. Okay, transition elements such as copper can merge with, let's say, it can merge with 4 water, it can merge with 2 ammonia, and the whole thing, the charge is 2 plus. Okay, no need to memorize. Understand? Alright, this fella looks complicated, it's complex. This fella got charge, is ion. This fella called complex ion. I get that? Transition element can form some very complicated fella got charge. That's called complex ion. Don't need to memorize the example. Clear? Okay, last one and no more. Okay, last one. Transition element can act as catalyst. Okay guys, a quick check here. How many of you in the classroom never ever heard, I don't say understand, how many of you never ever heard about catalyst? All of you heard about catalyst. Wow, that's good. Okay, so what is catalyst? Listen carefully. Catalyst is a substance that can speed up a reaction. Here, catalyst is a special substance, it's a magic ingredient that you added in to speed up the reaction. Here, I give you 2 examples, one chemistry and one a little bit bio. Okay, chemistry example. Again, don't be forget, some people heard bio. Just heard about bio, we scared. Alright, don't worry about that, okay, guys. Okay, I give you an example, guys. Yeah, don't need memorize. Okay. I have a process called XYZ, for example. This process initially takes 7 hours to complete. Okay, I have a process called XYZ. It takes 7 hours to complete. So today I take a transition element. Let's say this transition element called chromium, for example. Don't memorize that. I have a transition element called chromium. So if I put the chromium into the process XYZ, so the process, instead of taking 7 hours, now the whole process completed within 2 hours. Okay, that. You get the idea? So catalyst is a substance that you purposely add in to speed up the entire reaction. So far so good? Okay, alright, I show you another one. Okay, this is a little bit bio example again. Don't be phobia about bio, alright? It's fine, right? Okay, all of us as a human or living substance, we have catalysts in your body. Okay, we have some biocatalysts in the body, which is called enzyme. Alright, all of us, we have enzyme in our body. Enzyme is a biocatalyst which will speed up some biological process. Okay, you get it? For example, today, let's say I take too much food, I feel like bloated, alright? So I can take some enzyme that help me to digest. Okay? For example, I take a lot of carbohydrates. I feel very, very bloated. I'm not feeling well. I can take some enzyme that contains something called amylase. I take amylase. Amylase can help me to break down the so-called glucose, or we call it a carbohydrate. Understand? So that's the thing. Are you okay with that? This is a little bit bio, so no worry on that. So far so good, huh? So you only need to know a simple thing. What is catalyst? Catalyst is a substance, okay, that is added. Catalyst is a substance that is added to speed up a chemical reaction. So you purposely add this fella to speed up the chemical reaction. This fella is called catalyst. So far so good. And guys, transition element finish. This is everything you need to know. One word only. That's it. You know this thing, you will have no problem to solve transition element. Trust me. This is what you need to know for transition element. Okay? Alright, jot down this. Come on. Alright, so guys, can I have your attention for the last subtopic in this chapter, guys? We have covered transition elements. So now we left the last thing to go, which is period 3. You see, guys, everything we learned so far for the past 3 weeks, inclusive today, is all group, right? Group 1, alkali metal. Group 17, halogen. Group 18, noble gases. Group 3 all the way to 12, transition elements. Understand? So far we're focusing so much on group, all the vertical thingy, right? So now I think it's time for us to swap the focus. Let's learn the horizontal thingy. Okay, so we are learning period. The good thing is that period you only learn one period only. Okay? I like group, we learn 3 groups, right? Okay, period you need to learn one, which is period number 3. Come. So again, don't be easy to copy, pay attention, try to get the concepts I'm talking about. Then from here, you hopefully will have a much better idea what is happening. So listen carefully, what I'm going to show you regarding the period. Okay. So I'll show you what is the period you need to know and how to solve the thing. Right guys, here we are. We are now in period number 3. So remember, period is all the horizontal thing. This is the periodic table. So this horizontal portion is called period. Okay? And guys, can we recall back a simple thing? Group is decided by number of valence electron. Am I right? Period decided by what? Number of shells occupied with electron. Okay? Must mention occupied with electron. Many students make the mistakes. Okay? What deciding the period? Number of shells. Full stop. You cannot get move up. Understand? Number of shells filled up or occupied with electron. Clear? Alright. Now, we are learning period 3, which means that you expect this fella got 3 circles, 3 shells. Okay, first of all, I will show you the member for period 3. You all no need to memorize. you don't need to memorize the member of period 3. For period 3, they will give you, you don't need to memorize at all. Let me show you. The first guy is called sodium, symbol Na. Okay, 281. The second guy called magnesium, symbol Mg, 282. The third guy called aluminium, symbol Al, 283. The fourth fella called silicon, symbol Si, 284. The fifth fella is called phosphorus, symbol a P, okay, 285. The sixth fella is actually called sulfur. The symbol is S, 286. Alright? The next fella is called chlorine. The symbol is Cl. Electron reaction 287. The last fella is called argon. Alright? Some people pronounce as argon. Doesn't matter. Depends on you. No oral test. Pronunciation is okay. Alright? Ar 288. Understand? Guys, don't get frightened what is written on the whiteboard. You no need to memorize. Understand? Not even one. The whole thing they will give you. Here, they will give you you don't need to memorize the period. You only memorize the group. Understand? Alright? No need to memorize the period. Yeah. Okay. Now, you will change in the action. So, what it means by action? Okay, what it means by action, sir? Okay. Previously, when I gave you group, no matter group 1, 17, or 18, you will always heard about these 3 words. Moving down group. Am I right? Moving down group. What is moving down group? Top to bottom. Why we go from top to bottom? We want to see what is the changes on the trend or pattern as that. For example, moving down group, melting point increases. Moving down group, reactivity increases. Something like that. Clear? So when you are in a group, the only action you can do is go down. Understand? But now we couldn't do this, guys. In period, bottom, nothing, am I right? So you're not moving down. So when you're period, you move from left to the right. Left to the right, this particular action is called moving across. Left to right called across. Understand? So you are focusing on here. Now we are doing from the left all the way to the right. So left to the right, this particular moment or this particular action is called moving across the period. Okay, this particular thing called moving across period. Group, moving down. Period, moving across. And the direction cannot wrong, left to right, not right to left. Okay? Yeah. These are some small details you have to be careful. Okay, so moving across period, what you need to know? The first thing you have to know is that the properties changes. When you move from left to the right, you will see this. Metallic properties decreases. Metallic properties decreases. I'll tell you why, but you don't need to memorize, guys. What it means by metallic properties decreases means that you change from metal become not so metal. Are you okay with that? Make sense, guys? See, Sodium is a metal, right? Group 1. Yeah. Magnesium, group 2 is a metal. Aluminium got 3 outer electrons. Tell me which group? Group 13, not group 3. Understand? 3 outer electron must plus 10 become group 13. Group 13, are you still metal? Yeah, group 1 to 13 are metals, right? So metal, metal, metal. These 3 brothers, they are metal. Silicon got 4 outer electrons. Which group you are? 14, 15, 16, 17, 18. We all learned on the first lesson of this chapter. Group 14 all the way to group 18. Who are the non-metal? So you can see metal, 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 no metal, no metal, no metal, no metal, no metal. Can you see that? You change from metal, become non-metal now. When you change from metal, become non-metal, your metallic properties decreases. Does it make sense? Yeah? That's it. So you change from metal, become non-metal. You change slowly from metal to non-metal. So this is what I call it metallic properties decreases. So far so good. Okay, you no need to know the reason. Okay, in SPM, no need to know the reason. You don't need to know the reason why the metal become non-metal. No need to know. Too complicated for SPM. Yeah. The second thing which is very important, everyone tense up a bit, need to focus on this. This is very important. Listen carefully. I go very slow. If you don't understand, ask me on the spot. I'm teaching you the most important thing for period 3. Listen carefully. Yeah. Moving from the left to the right hand side, moving from the left to the right hand side, you will see this. Atomic size. Atomic size. Sometimes they use the word atomic radius. No problem. Because all the atom is in circle, is in a spherical shape. Sphere you can also denote it as radius. Understand? Yeah? Atomic size and atomic radius is the same thing. Alright? Good. Moving across the period, atomic size is decreases. You can say decreases or you can say becomes smaller. And this is very, very important. So let's put some star here. Star, star, and star. When I put star means important. 3 stars or more. Alright? Now why? Previously, all the while that we learned, recap, all the while what we learned, moving down the group, the size getting larger, right? Why? Simple more and more shells. Am I right or not? 2 circles, 3 circles, 4 circles, 5 circles. So when you're going down the group, you have more and more circles, of course you become larger. That is easy, right? But not for this. Why? Everyone, let's try to think and use common sense. Let's brainstorm together. This furler is 281. How many circles you have? 3. Blah 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 blah. This furler 288. How many circles you have? 3. That's the thing. Put on. From here to here, the number of shells, the number of the circle is the same. How come you have 3 circles? I have 3 circles. Our size is different. You get an idea? Okay, I give you some ideas so you can draw this. Okay, sodium, the size is like this. When you go until argon, the size is like this. Are you getting that? You don't even know how to draw. Okay. But I want you all to know something is quite awkward now already. Because normally, when you and me all got 3 circles, 3 shells, by right our size should be the same, right or not? But it's not. Why? Listen carefully. I drew a picture. I hope this picture help you to understand better. If you don't understand, please ask me. I try to change another way to explain. Okay? Yeah. So we use sodium and argon for demonstration. Now let me do demonstration and I'll write the answer here. Okay, I do a very quick demonstration over there. Okay? Quick one here. Let me do a quick demonstration here. Okay. This is a sodium. Sodium have 281. Okay. So how many circles? 3. 1, 2, and 3. So this is 1, 2. This is 1, 2, 3, 4, 5, 6, 7, 8. This is 1. Don't forget you have a small circle called nucleus. Understand? Yeah? Okay, one more. Okay, look at another fella called argon. Okay? So argon have the arrangement 288. I use 2 for demonstration. The rest is the same. 288 supposedly is 3 circles. 1, 2, and 3. So you have 2, you have 8, you have 8. Both of them have 3 shells, both of them got 3 circles. But how come the size is different? Listen carefully. Guys, all the electrons, they stay in the shell because there are something pulling them. Okay, for example, moon always moving, circulating the earth because there is a force pulling the moon. Am I right? What is the force? Gravitational force. Am I right? Okay, now bridge the whole thing into chemistry. In chemistry, all the electron, like the moon, so all the electron moving and they revolve around the center. How come the electron keep moving in the shell? How come the electron not go there, not go here, but they move in this way? What is the force pulling the electron? Nucleus. Understand? Cannot use van der Waals, cannot use metallic bond. Why? Van der Waals and metallic bond only for melting or boiling point. Can we do a final revision since we are closing at this chapter already? When we use van der Waals forces, if I am going to melt a non-metal. When we use metallic bond, the name damn obvious, right? Metallic bond, when we want to melt or boil a metal. understand. Van der Waals and also metallic bond only for melting boiling point. I don't want to see them in other cases. Clear? So today very simple. What are the force that pulling the electron? Nucleus. Understand? Okay guys, we dig down further. Guys, zoom in. When we go into the nucleus, who is in the nucleus? We learned in chapter 2. Got two further in the nucleus. One. Proton. One more. Neutron. Fantastic. There's proton, there's neutron in the nucleus, right? Got on. Okay guys. Neutron got charge or not? No, right? Proton got charge or not? Yeah. Got, Proton got charge, Just in case you forgot, guys. Just in case you forgot, Okay. Proton, the charge is positive. Neutron, there is no charge at all. Okay. Neutral, Neutron have no charge. Okay. Electron carry what charge, everyone? Negative. Okay. Now ask yourself a simple question, I say just now, all the shell, all the electron pulled by the nucleus. But nucleus got two further inside, proton and neutron. Who do the pulling job? Proton. I know, alright? Electron is negative charge. Inside there got neutron. Neutron is neutral. Neutral won't pull any people. Clear? Alright? But inside the nucleus you also have proton. Proton is positive. Positive proton pull negative electron. Understand? You get the picture? Okay, now zoom in here. In sodium, how many electrons we have? 281. Total how many? 11. When you have 11 electron, you have 11 proton, right? So inside here got 11 proton, 11p. So argon 288, total 18. When you have 18 electron, you have 18 proton. Understand? Now you imagine, you got 3 circles, I got 3 circles. Inside the circle, I got 11 people pulling the 3 circle. But here, I got 18 people inside pulling the circle. Did you get the answer now? Of course, this is stronger because you have 18 people pulling the 3 circle. This one, you only have 11 people pulling the 3 circle. Am I right? So this pulling force is stronger, right? So when the pulling force is stronger, the whole thing gets smaller. Makes sense or not? Get it? Can you imagine a bit? I want you to imagine. Don't memorize all these statements in your what you call it, reference book or so-called your textbook blindly. Here, imagine it. Okay, how you put in words now. Okay, how you put in words? You write this. Okay, this is the reason. Okay, how you write it out? Okay, when you're moving across the period, when you're moving across the period from the left to the right, number of proton increases. Number of proton increases. You have more and more proton in the middle, right? When you have more and more people in the middle, you have a stronger pulling force. Okay? Force of attraction. Force of attraction between your nucleus and also the electron become stronger. Okay? Force of attraction between nucleus and also the electrons eventually become stronger. So when you have a stronger pulling force, therefore the size is shrink. Understand? The size becomes smaller. Everything very hard, right? But you must understand the logic behind. Don't memorize blindly. It's tough. Are you here with that? I always say, you don't study chem like how you study bio. Here, you don't simply memorize everything without understanding. That's tough. So far, so good? Okay? So I want to make sure that you all can understand this statement. Are you okay with this one? Yeah? Jot down this. Come on. Guys, before I go on, just have a bit more to go. The next thing I'm going to show you is what? Sometimes the question will ask us to arrange or sort out the size. I repeat, sometimes the question will ask us to sort out the size. Okay? So I'll show you how the question works and listen carefully. I'll give you a sample question. How they ask you. Sometimes they love to give you a periodic table and ask us to sort out the size. See, alright. In SPM, okay, it is very common, it is common that the question will actually give us a periodic table. They will give us a periodic table, okay? Then they ask us to arrange the size. They can ask us to arrange the size of those atoms, okay? In a very specific order. What it means by specific order, there's only two possibilities, ascending or descending. Understand? Which means that you either sort out the size from small to big or big to small. That's it. Here, no other possibility, okay? Ascending or descending. Okay guys, the best way to learn is by example. Okay, let's use one example. Before that guys, let me give you a concept first. This is the concept that we try to use a question for demonstration. Okay guys, we are trying to merge everything we learned so far up to now in this chapter. Listen carefully. We all learned few weeks back, 3 weeks back, when you go from top to bottom, we call it moving down the group. So when you're moving down the group, when you go from top to bottom, what is the impact or what is the consequence? Okay, your size is getting bigger, okay? The size become bigger. Very good. Okay guys, the second thing is something we learned a moment ago. Now, what if we go from left to right? Left to right, this particular action called moving across period. So when you're moving across the period, when you're moving from the left all the way to the right, so what happens is that your size is getting smaller. So this is what you should know. Here, top to bottom size become big, left to right size become small. Okay, how they ask us a question. So let's say I use a sample question for demonstration. Okay, we use a sample question for demonstration so that we have a rough idea what is it all about. Okay, so this is a periodic table they give me. Just assume this is a periodic table. Okay, of course it's not complete. This is a periodic table, a random one. Okay, you can choose not to copy later to show you. Okay. Let's say I go for some random one. I go for some random one. This fella I call X. This fella I call Z. This fella I call C. This fella I call donkey. This fella I call A. This fella I call it as B. Okay, that's it. All right. So the question asks us to arrange the element. Okay, arrange the element size in ascending order. That's what the question asks me. Arrange the element in ascending order. So you want ascending. Ascending means small to big. All right. Ascending means that we want to try from small all the way to big. So now your first job is to find out who is the smallest one. So when you go for these kind of things, you always prioritize period. You prioritize period, and it makes perfect sense. Why? You think in a simple way. D is in period 1, D got one circle, one shell, right? B is in period 2, B got two shells, two circles. Z, X, and C in period 3, they have 3 circles. Alright, A is in period 5, it has 5 circles. You can clearly see who is the smallest one, the one with the least circle. Am I right? So the smallest one is donkey. So donkey is the smallest one. Are you hear that? Because you got 1 circle. Now the subsequent one, who is it? B. Because B got 2 shells, we got 2 circles. 2 circles a bit larger than 1 circle. Am I right? So it's B. Okay, now the next one a bit trickier. What about here? Go for here. Now you're in period 3. Z, X, and C, all these 3 fella got 3 shells. All of them have 3 circles, right? How to know who big, who small? You look at the trend. Going across the period, size becomes smaller. Right hand side smaller than left hand side. Okay? Right hand side smaller than left hand side. So who is smaller? C. So C smaller than X, smaller than Z. Are you get that? Alright, right hand side smaller than left hand side. Okay, next one. Period number 4, 4 circle, no candidate, right? Period number 5, 5 circle got A. So 5 circle, largest one. Huh? Are you okay with this? They love it. This is a very, very popular question in your paper. Understand? Alright, your midterm paper, very likely they will ask 1. Okay? So when you have a question like this, you should be careful with 2 things. Ascending or descending. Not every time from small to big, sometimes big to small. Watch out the keyword ascending or descending. Clear? Alright? So if today they want the largest one, what to do? You see who got the most circle. Clear? If let's say, hey, I go to period number 7, got 7 circle, very big. Hey, period number 7 got 2 further. How to know who big, who small? You see who's on the left, who's on the right. Understand? When we are in the same period, right hand side smaller than left hand side. Clear? Make sure you know that. So far so good? Alright, very good. So settle. Okay, now we covered the last thing. Okay, let's cover the second last thing. The second last thing we will learn is this. Okay. This is a very good answer. I'll tell you why. I'll tell you why this is a good answer here. Okay, now you don't need. We can just modify a little bit here. Okay, now I want to show you this. This is very important. Please listen carefully. Okay, now moving across the period. When you move across the period, when you go from left to the right hand side, there is another super important thing you must know. It sounds a little bit tricky. It sounds quite technical, but you will be fine. You just follow me. When you go from the left to the right hand side, okay, I want you all to know this one. This thing sounds quite fancy, sounds a bit more technical. Going left to the right hand side, electropositivity will actually decreases. When electropositivity decreases, at the same time, electronegativity will increase. They just opposite to each other. You just memorize one. You memorize electropositivity decreases, the opposite one, electronegativity will increase. Understand? Now, don't worry, I will tell you what is it. What is electropositivity and what is electronegativity? And don't get frightened by this, it's quite simple. Now, over the space here, okay? Now, I want to teach and make sure all of you know what is electropositivity and what is electronegativity. Let's understand the concept first. And we will try to use some common sense. Alright? Now, let me tell you the proper definition first. Then I tell you how to memorize. Electropositivity is the tendency, or we call is the ability for you to donate electron. Okay? How keen you want to donate electron. If you are very keen to donate electron, you are very electropositive. Okay? No repetition to memorize later. Second one, opposite, the balik one, electronegativity. What about electronegativity? So this one is donate, this one is receive. So this is the tendency or the ability for you to receive or accept electron. So not hard, guys. One donate, one receive. I hear that. Now the problem is what? So I know one is donate, one is receive. Sometimes I confuse myself. Sometimes I forgot which one is donate, which one is receive. Understand? Okay, now. Again, if previously you already know this, if previously you already understand, it's not a big deal. But if you are a person who always blur and you feel this is a bit confusing, I teach you a simple way. Okay? It's nothing in chemistry, it's called common sense. How to use common sense? Look at here, how to use common sense. How to know electropositivity and electronegativity, who will take, who will throw. Listen up. I use the diagram to show you. Everyone put your eyes on here. Give me 2 minutes. I try to make sure you can understand. This is me. This is me, okay? Inside my head got an electron. Yeah? Okay, I ask you a simple question. Guys, electron carry what charge? Negative. Okay. Today, if you throw the electron away, if this electron throw away, guys, again, electron what charge? Negative. If you throw negativity from your brain, you become a more positive person. You get the idea? Common sense, right? Okay? Vice versa. Today, alright, I am neutral, my brain got nothing. Alright, okay, my brain got nothing. So I met up with some person. So this person give me some electron. Electron is negative. I accept negativity from people. I become negative. You get the idea? Common sense. Get it? Alright, when you throw the electron away, you throw negative away. You become positive. When you take in electron, you take negative into you, you become negative. Understand? This is nothing to do with chemistry. This is common sense. Here, you got a picture. But if you don't have common sense, I cannot help you. Alright? I try my level best, make it as simple as possible. Is it okay? Does it make sense to you? Alright, good, you got common sense. Alright? Okay. So you can see how it works, right? Not very hard, huh? Guys, come. Now, let's finish it. Come, let's finish it. We just left a short line to get it done. We almost finished already. Okay, guys, now, moving across the period, how come electropositivity decreases? How come electronegativity increases? Okay, the good thing here is what? You can go to use exactly the same answer that we used to explain the size. We use exactly the same answer we used for the size just now. What is it, everyone? Imagine, going across the period from the left to the right hand side. From the left to the right hand side, when you're moving across the period, when you move across the period, when you go from left to right hand side, you got more and more proton. So the number of proton increases. You have more and more proton in the nucleus. So when nucleus got more and more proton inside, when you have more and more people in the proton, what happened? Stronger pulling force, right? So force of attraction between the nucleus, strong force of attraction between nucleus and also the electron eventually become stronger. Now guys, listen. When you have a strong pulling force, when the pulling force is very, very strong, from here to here, the pulling force becomes stronger and stronger. Is it easy to throw electron? Is it easy to throw electron? No, right? Because the pulling force is so strong, this electron get hold tightly. This electron cannot get out. Understand? So it becomes harder to donate electron. If you don't want to write donate, you can write the word lose. If you don't want lose, you can write the word release. It's harder to release electron. But at the same time, when it becomes a very strong pulling force, it becomes easier and easier to take in the electron. Understand? So eventually it becomes easier for you to take in electron. You can call accept, you can say pull, you can say gain. Okay? Electron. Are you okay with that? Yeah? That's why move across a period, it becomes harder to donate but easier to release. If you being observant, this answer is what we used just now for the size. Am I right? So that's why this answer, I call it one stone hit three birds. One answer can use for three cases. Understand? Today if they ask me, Martin, why moving across the period the size becomes smaller? This answer. If they ask me, why moving across the period electropositivity decreases? This answer. Okay? If they ask me, why moving across the period electronegativity increases? This answer. Here, you use the same answer for three scenarios, for three situations. Understand? That's what I mentioned early on today, just now. This is the most important thing in period 3. Understand? If you notice, most of the explanation in period 3 is workable now. So far, so good. You understand what is happening? Great. Okay? So make sense, huh? From left to the right hand side, there are more and more proton in the middle. The pulling force in the middle is getting stronger and stronger. When you have a strong pulling force, it's hard to throw. When you have a strong pulling force, it's easy to take. That's why your electropositivity decreases, but electronegativity increases. Does it make sense? So don't be panicked, you need some time, okay? So just jot down, and while you jot down, try to think about it, okay? If you still find it a bit confusing, feel free to ask me. So far, so good. Alright? Okay, so guys, now let's go to the last part of period 3 as well as last part of this particular chapter. Okay, I'm going to close up this chapter already. Yeah? So the last part for this chapter is this. We have learned physical properties. Yeah. So now let's look a little bit on chemical properties. Okay. So let's look a little bit on chemical properties. It's just some simple statement. So just listen to what is it. Okay, and we will see how it goes. Yeah. Okay. So the first thing I want you all to know is this. All period 3 elements, okay, they can react. All period 3 elements, they can react with oxygen. All period 3 elements can react with oxygen, okay, in order to form oxides. Make sense now? We learned before, anything combined or merged with oxygen, the final outcome called oxides. Okay, man? Alright? If you merge with chlorine, you call chloride. Understand? Huh? So all period 3 substance can react with oxygen to form oxide, except one fella, except the argon. Argon cannot. Why? We learned before. Argon belongs to group 18. So everyone in group 18, their outer shell already fully occupied with electron. In the other word, they are stable. Understand? So all the group 18 already stable. When you are stable, you don't want to react with any other fella. Understand? Yeah? Okay, now these are the examples for oxide. So no need to memorize. I'll give you this. So you don't need to memorize the formula for oxide. All the formula of the oxides you don't need to memorize. I only want you all to know some concept. The first fella is Na2O, sodium oxide. Right? You have MgO, magnesium oxide. Al2O3, aluminium oxide. SiO2, silicon dioxide. P4O10, phosphorus oxide. SO2, sulfur dioxide. Cl2O7, chlorine oxide. Don't need to memorize it. You don't need to memorize the formula. You don't need to memorize the name. Here, I just want you all to know all period 3 fella can form oxide except argon. Argon will not react with oxygen. Okay, I want you all to know a simple thing here. I want you all to know a very, very simple thing here. Yeah. Alright. So I want you all to know that for oxides, alright, there are 3 possible behaviors of oxides. There are 3 possible behaviors of oxide you must know. The first one, okay, we will touch a little bit more on next week for some exercise only. Alright, so but let us finish the concept today. Oxides have 3 possible behaviors. The first behavior called basic. You have something called basic oxides. The second behavior is called acidic. Your oxide could be acidic oxide. The third one is called amphoteric. We call it amphoteric oxides. So these are 3 types of oxide you must know. So give me 5 minutes, let me explain to you what is what. Clear? Alright guys, what it means by basic oxide, you learn the word base when you go to Form 4 Chapter 7. For now, I want you all to understand and assume base means alkaline. So basic oxide means that this oxide got alkaline properties. If your oxide got some alkaline properties, your oxide is, your oxide is alkaline, so we call it basic oxide. Acidic oxide, I don't need to tell you the name, kind of self-explaining, right? Acidic oxide means the oxide is acidic, right? So acidic oxide is the case whereby your oxide got acidic properties. Yeah, if you have acidic properties, your oxide called acidic. Amphoteric is a special oxide. Amphoteric is a special oxide. I call it, okay, again, I like to give a nickname. I love to call amphoteric oxide as a bisexual oxide. I love to call amphoteric oxide as a bisexual oxide. What it means by bisexual here, they have acid and alkaline properties. They have both. They have both, okay? Amphoteric oxide is the oxides that contain or they have both. These fella have both alkaline as well as acidic properties. You have acidic properties, you also have alkaline properties. You have both. That is called amphoteric. Understand? Now, what you should know and how you use this in your SPM. Listen carefully. Who is basic oxide? Everyone put your eyes on here, copy in the shop. Yeah? Give me 1 minute. Basic oxide is what? How you know this fella is basic oxide? All metal oxide are basics. Today, when you have a metal oxide, any metal merged with O, the metal oxide, they are basics. They have alkaline behavior. Alright? So who is acidic oxide? Very simple. Alkaline is metal, acidic should be non-metal. So all your non-metal oxides would be acidic oxide. Understand? Alright? And it makes perfect sense already. Recall back, we all learned this a few weeks ago. Group 1, when they throw in water, they form alkaline. Correct? Because group 1 is metal. If you remember from last week, chlorine or group 70, if you put in water, what do you form? Acids, right? Or not? Makes sense, right? Correct? Metal, they are alkaline or basics. Non-metal, they are acidic. Here, for your level, who is aluminum oxide? Let's do this one. For your level, there's only one aluminum oxide you need to know for your syllabus. Aluminium oxide. Aluminium oxide is the one and only amphoteric or bisexual oxide you need to know for SPM. Now, can we make a wild guess here? Look at here. Sodium oxide, magnesium. So you see, very simple one. Aluminium oxide is the amphoteric oxide. So it got both acidic and alkaline behavior. Sodium oxide and magnesium oxide, they are metal oxide. When they are metal oxide, so they are metal oxide, so therefore they are basics. Okay, they are basics oxide. What about this? Silicon dioxide, phosphorus oxide, sulfur dioxide, chlorine oxide. So all of them are bunches of non-metal, right? These are a bunch of non-metal merged with oxygen. So they are non-metal oxides. So when you have non-metal oxides, you should be acidic. So they are acidic oxide. So far, so good. Clear? That's it. So you use this concept, it works one. For example, today I give you a random one. I say copper oxide. It's not here. I say make a wild guess. Copper oxide. You think it's basic, amphoteric, or acidic? Basic, because copper is a metal. Metal oxide is basic, although not in your list. Understand? Alright? That's how you do your judgment. Example, today they give me a carbon dioxide. Is carbon dioxide in the list? No! But carbon dioxide, the carbon is a non-metal. So carbon dioxide is a non-metal oxide. You are acidic. Here, when you know the principle, even they ask something a bit off, not in here, you still can do. Here, right? So, here we are, we have finished with your chapter 4. Yeah? Your chapter 4 all done already. Not very hard, Not very hard. As long as you learn in a proper way. So next week, we will start with chapter 5, okay? We'll start with chapter 5, alright? It's a very short chapter. We just need 2 lessons, we can finish the entire chapter already. So next week, please make sure you still bring along an exercise. I'll spend 15 minutes to do exercise with you. Then only we can start with the new chapter. Okay? So please make sure you still bring along your objective and your subjective booklet next week. Okay? I'm going to use it for one last time. Yeah? Alright, I think that's all. I'll see you next week.